Good day everyone, it's me again, Rizal J. Diaz. So, welcome back to my YouTube channel, and for today's video, we'll be discussing about the binary tree in data structure. So, when we say binary tree, it is a structure that is used to represent and organize data in a way that is easy to navigate and search. It is a collection of nodes that are connected by edges and has a relationship between the nodes. The topmost of the three is called the root, and the nodes below it are called the child nodes. Each node can have multiple child nodes, and these child nodes can also have their own child nodes, forming a recursive structure. So now I have here a code, and let's try to explain it line by line. So here we declare the beginning of the BST class, and then next is we declares an inner class node within the BST class to represent a node in a binary search tree or BST. And the next we declare an integer variable key to store the data value of the node. And the next, this one, we declares two reference left and right representing the left and right children of the node. And the next, this one is our constructor for the node class that initializes a node with a given data value. And next, this one will complete the constructor by setting the key to the provided data and initializing left and right children as null. And the next, this one, so we declares a variable root of type node to represent the root of the binary search tree. And the next, this one is our constructor for the BST class, or initializes the root of the BST as null. And the next, this one will complete the constructor by setting the root to null. Then this one, we declares a method delete key that initiates the deletion of a key from BST. So next, this one will initiate the recursive deletion by calling the delete recursive method in the root. And then this one, we declares a recursive method delete recursive to delete a node with a given key. And the next, this one will check the current root. This one will check if the current root is null, indicating an empty sub-tree, and returns it. And then this one, if the key to be deleted is smaller than the current root's key, recursively call the method in the left sub-tree. And then next, this one, if the key is greater, recursively call the method on the right sub-tree. And then else statement for the execution when the key to be deleted matches the current root's key. And the next, here, if the left child is null, replace the root with its right child. And then the next, this one, so replace the key of the current node with the minimum value in its right sub-tree. And then here, this will be the one who will continue the deletion process recursively and return the modified sub-tree. And the next, this one, we declares a method mean value to find the minimum value in a BST. And then this one, we initializes min val with the current root's key. And then here, while statement, so we transverse the left sub 3 to find the minimum value. And then here, so here where we returns the minimum value found in the leftmost sub 3. And the next, this one, we declares a method insert that initiates that the insertion of a key into the BST. And the next, this one, so it initiates the recursive insertion by calling the insert recursive method in the root. And then this one, it declares a recursive method insert recursive to insert key into the BST. And then next, here in our if statement, if the current root is null, create a new node with a given key. And then so here in our if statement, if the key is smaller, recursively call the method in the left sub 3. And then here in our else statement, if the key is greater, recursively call the method in the right sub 3. And then here, this will be the one who will return the modified sub 3. And then next, so here we declares a recursive method in order recursive or in order transversal. I mean here. So we declare a recursive method in order recursive for in order transversal. Then here, this one will check if the current root is not null. And then here, we recursively transverses the left sub 3, prints the current node's key, and then transverses the right sub 3. And then here, we declares a method search that initiates the search for a key in DBST. So here, if the modified root after the search is null, it will so here, if the modified root after the search is null, returns true, otherwise returns false. The next, here we declares a recursive method search recursive to search for a key in the BST. And then this if statement checks if the current root is null or if its key matches the search key. If true, returns the current root. So here, it will continue the search recursively based on whether the key is smaller or larger than the current root's key. And then this is our main method. This is our class main. Then this is our. Then here we declares the main class and its main method is stored where we stored our program. So next, here we create an instance of the BST class named BST. So this is our BS binary, I mean this is our BST3 example. So next, so here, this is where we insert the specified values into the BST, creating the example 3. And then this one will print the message and initiates an in-order transversal of the BST to display its elements. So next, message deletes the node with the key 12 from the BST and then prints the BST after the deletion. And then here, it will print a message, deletes the node with the key 90 from BST and then prints the BST after the deletion. And then here, it will print a message, deletes the nodes with key 45 from the BST and then prints the BST after the deletion. The next, so here, this is where we searches for the key 50 in the BST and prints whether it is found. And then here, this is where we search for the key 12 in the BST and prints whether it is found and ends with a and ends the main method using the first closing curly brace and then followed by the next closing curly brace. So this is now the output.